So this is the big rule from yesterday. And remember, in simple terms, the rule basically is this. If you have things that are the same radical, you can put them together, or you can pull them apart. That's pretty much the rule. All right? We're going to use that a lot today. So this is where we left off yesterday. Let's dive into some new stuff. Stuff that looks like this. All right.
Oh, Lord.
All right.
That's when I want to get off myself. Yeah, maybe like.
All right, here's the deal. You might be looking at that thinking, holy crap, there's no way I can do that. But it's not true. You have the skills to do this. It just looks differently than anything we've done, which is okay. That doesn't mean you can't do it. All right? Just because something is new and unfamiliar, that doesn't mean you're incapable of doing it. You have the skills to do this. We just got to put the skills in the right place. So it's asking you to simplify the fourth root of x to the fourth divided by y to the eighth. Well, let's kind of break it down one thing at a time. If you look at x to the fourth divided by y to the eighth, can you divide those things?
No,
No, why not?
because they're different things.
They're different bases
Variants.
or variables, whatever you want to say. It's x and y, so you can't divide them, you can't simplify those at all, so we can't do anything about that, okay? Can I apply a rule here, though?
Yeah.
What could you do?
Well, you can take the fourth out because it's both on, the x out because they're both on 4.
We are going to do that, but you're kind of skipping the step to get there.
Divide everything by something.
Kind of.
You can say the fourth root of x to the fourth over the fourth root of y to the eighth.
Yep, so you're saying apply the root to both things, Brandon's saying split them up, right? That's the rule, because this is all, both these things are underneath a fourth root. So the rule is I can break them up. They're all underneath that root, so let's split them up. Let's give the root to both pieces individually. Fourth root of x to the 4 and fourth root of y to the 8th. Okay, now those, if you look at each piece individually, those look a lot like these. Yes? So now you know what to do. We can figure this out. Let's just use a shortcut. How many times is 4 going to 4? Once. So what is it? It's just x. And how many times is 4 going to 8? 2. With no remainder, right? So it's just y squared. That wasn't too bad, right?
That's the answer?
That's it. That's all you can do. Okay, the reason I know I'm done, I don't have any negative exponents. I don't have any other radicals to deal with. I can't combine these things because there's different variables. So there's nothing else that I can do, and that's the signal that tells me I'm done. Okay? We all right with that? Okay, let's look at another one. This guy. Again, it looks kind of weird. It looks kind of strange. That does not mean you can't do it. All right? You got to kill that negative self-talk. Says you can't do something. You can do it. You got the skills. We just got to hang in there for a little bit. All right? Can you combine these things right now?
No.
Nope. What can you do? Separate them. Again, they're all underneath the same root. What kind of root is this? It's a square root. There's no 2 there, but I know it's a square root. They're all underneath the square root, so split them up, just like we did here. Break them up. Give the square root to each piece individually. So it's the square root of a to the 4th times the square root of b to the 8th times the square root of c to the 6th. You guys kind of seeing how these work?
Yeah.
Because now you can figure those out, right? What is the square root of a to the 4th?
A squared.
How do you know?
Because 4 goes twice on 2.
Yeah, there's 2's here, right? We don't write them all the time, so we're doing the same trick. 2 goes into 4 twice, 2 goes into 8
4 times.
4 times, and 2 goes into 6 3 times. So here's our answer. So far, so good?
Yep.
Okay. I want you to try these two on your own. This one is just the same kind of problem that we were doing here, right? Nothing new about that. This one is a little new. Okay, so give those a shot. Take a couple minutes. Try them out, and then we'll talk about it. All right, let's talk. I'm just going to do the last one, all right? I think we probably are able to do the third one. We've done a lot of those. So let's talk about the last one. I got fourth root of all this stuff. So what should I do first?
Divide it into the 3 pieces.
Yeah, break it up. Give the root to all 3 pieces. Fourth root of x to the 5th times fourth root of y to the 7th times fourth root of z. If you hadn't, what? Yeah, I'm just splitting them up. Yeah. If you haven't picked up on it yet, on these types of problems, you are pretty much always, the first thing you do is pretty much always going to be either splitting stuff up or putting stuff back together. That's pretty much always what's going to happen. Okay? But there's a problem here. If you start doing shortcut, 4 goes in, what's wrong? It doesn't go in evenly. It doesn't go in evenly, which is fine, because it doesn't always go in evenly, like this one. That's okay. So we know how to handle that. We know what to do if there's a remainder. We just have to do it 3 times. We just have to do it with each individual piece. That's okay. All right, so how many times is 4 going to 5? 1. So it's x with a remainder of 1. That goes underneath the fourth root, right? Remember, there's 1 right here. You just don't have to write it. Okay, so that's that piece. Let's go to the next one. How many times is 4 going to 7?
1.
So y with a remainder of what?
Y2.
Y to the 3rd. And then on to the last one. How many times is 4 going to 1? None. So what are you going to do with this? Nothing. You can't do anything with this. So you just leave it as the fourth root of z. There's nothing you can do. Just leave it alone.
Is the thing done now?
Not quite. Not quite. I think there's one more thing that you can do.
Well, you can put everything back together.
Yeah, here's what you can do. This has a fourth root. This has a fourth root. This has a fourth root, right? Those are all the fourth root. So I can clean it up a little bit by taking all those fourth roots and putting them back together so that it looks just a little bit less ugly. Okay?
Can you do that and then times x times y?
Yep, so x, y is going to be in the front because those are not under a root. So I got x, y. And then I have the fourth root of all this crap. X, y to the 3rd, z. Cool with that?
Sure.
There it is. All right, so again, you know you're done if there's like no negative exponents. There are no radicals to simplify. You can't combine any more variables. Those are some triggers to tell you that you're done. Okay? So we know that we're done here. Questions on that at all? Nap time? What are you talking about, nap time? We got stuff to do. Let's dive in and talk about some other ones. I guess we already dove in. We're swimming right now. Woo! Man. Look at these.
What happened in that? No, it's a really horrible test. No,
All right, here's the guys. Here's the deal that I'll cut with you. If you can get through this slide with me, we'll take a break after this. Sound good?
Yes.
All right.
I know there's like methods.
Okay. 16 y to the negative 8th power, all raised to negative 3/4 power. Ooh. Love it. My heart is beating so fast.
I wish mine was.
Yeah. Why would anybody do drugs when you could just simplify this?
Dare not to do drugs.
Hey, just say no. Just say yes to simplifying.
Hugs not drugs unless they're free.
All right, here we go.
Don't do meth. Do meth.
Here we go.
Don't do meth. Do meth. Anyway.
There's a couple of things that you could do to start this, all right? And this is where these problems get a little confusing because there's not one perfect way to go about it. There are multiple ways that you could do problems like this, and all of them are just as effective. Okay, so you might approach this differently than I will. That's okay, because I bet that if you just stay within the lines, you'll get to the same thing. Amelia, were you going to say something just now?
No, I was just thinking.
Okay.
Okay, can I have an idea?
All right, well, what do you think? What might be a good first thing? Yeah.
Put it in the fraction.
Put it in a fraction. So, turn this into a radical. Is that what you're saying?
No, put a 1 over it and then you get rid of the negative exponent.
Oh, because you want to flip it.
Yeah.
Because they're negative exponents. Yes. I would agree that is probably a good thing to do. You could start with that. So that might get a little confusing though because this is negative.
Exactly. Should we start putting everything under the fourth root?
You could start like that too.
And then multiply the 8 and the 3. I think it's multiplying that you do.
You could do that. What are you thinking?
We should deal with the exponents first.
Sure.
Okay,
Can you multiply negative exponents if you're doing a even root?
Multiply the exponents?
Yeah, the negative.
I think
Yeah. So just right there, guys, those were 3 different ways to start this problem, all 3 of which are totally fine. Okay? So you got to trust yourself. If you think you know how you want to start, just try something. Just get rolling with it. And then it'll, as you go, one step at a time, it'll start to get simpler and simpler. Okay? Here's how I would do it. You don't have to do it the way I would do it, but this is how I would do it. I would say, well, I'm raising both of these pieces to this power, right? So I would just split it up. Remember, we're talking about breaking stuff up, right? So I would break it up into 16 to the negative 3/4 power, and then y to the negative 8 to the negative 3/4 power. That's how I would get rolling with it. If you want to flip stuff first, you can do that. If you want to turn it all into a fourth root, you can do that. It's okay. You just got to hang in there when it starts to get weird.
Yeah, that's what I'm doing.
All right, so now I have 2 things, 2 individual pieces. I'm going to look at them one at a time. All right? I'll kind of maximize the space of my board right here. Let's do it like this. Let's look at this one. 16 to the negative 3/4 power. Well, that's a negative exponent, right? What do negative exponents do? Bad. By bad, do you mean flip?
Yes.
Yes. They flip 1 over 16 to the 3/4. Okay? Well, I don't know what 16 to the 3/4 power is, but what can I do with this? I can make it a radical. I can turn it into 1 over the 4th root of 16 cubed. So you see how we're kind of taking all these rules and we're having to use them at different times here?
Oh my God, that number is ginormous.
We got all these moves, and you just got to know when to make the right move at the right time. What's the 4th root of 16?
4,096. Oh.
Try 2.
I did it too, but
Yeah,
it's
okay. The 4th root of 16 is 2.
You can do that, and then you should do
You'll get 7.
4th root, yeah.
And what's 2 cubed? 8. Okay, well, all of that to find out that 16 to the negative 3/4 power is, in fact, 1 over 8. Okay?
That's just crazy, dude.
So this is going to turn into this. Okay with that?
Yeah, I guess so.
All right, let's look at the other piece now. Let's look at this thing. Y to the negative 8 raised to the negative 3/4 power. Again, you might say, oh, this is negative, I'm going to flip it. You can do that. You just have to raise the top and the bottom to this power, which would mean you flip it again. It's a lot of flipping, right? It's okay. You're going to get the same thing, it's just might be a little bit longer.
You're flipping it over and over, can't you just do them without the...
Well, watch what's going to happen. Power to a power, what do you do with those numbers?
Multiply.
You multiply them. What's a negative times a negative?
Positive. That's crazy.
So 8, we got to multiply a fraction here. Oh, gosh.
Oh, no.
8 times 3 over 4, do it over here. 8 times 3 over 4, remember you can write that as a fraction, multiply top, multiply bottom,
Oh.
that's 24 over 4, right? You guys okay with that?
Sure.
Multiplying fractions, so this turns into y to the 24 over 4 power, and now it's positive, because the negative times the negative is positive. What is 24 over 4? That wasn't too bad, right? So I'm doing 8 times 3 over 4. So I wrote it as 8 times 3 over 4, but you can think that it's 8 over 1, right? Then multiply fractions, top times bottom. What?
Where did you forget those other?
What other numbers?
Did you just switch the days like the number 8? What? So what's the difference?
So I was doing 8 times 3 over 4. I wrote it as 8 times 3 over 4, but then I just put this over 1. Because anything is over 1, right? And that allowed me to multiply the fractions. Okay with that? Alright, we're almost done. This became this became this. So my answer, do it in a different color. My answer is 1 over 8 times y to the 6. Or if you want to simplify that a little bit,
I know.
this is a fraction. You can think about this as a fraction, right? We're going to start doing this a lot more. Put it over 1. We're multiplying. So on top, I have y to the 6. And on the bottom, I have 8. And that's where I'm done. Again, I know that I'm done because there's no negatives. There's no radicals for me to simplify. There's no variables for me to combine. Can't do anything else. And I'm done. All right? You okay? If the answer is no, that's okay. Because you just saw it, you don't need to be a pro right away. We're going to practice it. So let's keep rolling so that we can get to a break. Okay? Woo! It gets better.
For who?
It gets better. The ride never stops. Okay. You're going to approach this one very similarly to the way that we approached this one. Okay, but there's just one thing we got to do at the beginning. I know that there's a negative 1/3 out here. We're going to deal with that, okay? But before we deal with that, let's simplify the inside first. And then we will deal with that, okay? So think numbers, and then think variables. Numbers, then variables. What's negative 16 divided by 2? Okay, so this is negative 8. What's x to the 17 divided by x squared? Think exponent rules. You're dividing, so what do you do with the numbers? Subtract them. So it's x to the 15th. Remember, those are those algebra 1 exponent rules that we talked about. When you divide, you subtract the numbers. That's a 15.
And we put the parentheses around the...
Yep, so I just turned this inside piece into this. So now that whole thing is raised to the negative 1/3 power. All right? Now, this looks a lot like what we had here, right? Similar type of setup. So if you want to flip this whole thing first, you can, because it's negative, right? So you could flip the entire thing first if you wanted to. Or you could split them up and raise them both to the negative 1/3. Either way is going to be okay. Yeah.
For the negative 8x, what is the connected to x? Like what number is that?
It's a 15. I'll just rewrite it. Okay. All right. So like I said, you can either flip this whole entire thing or you can split it up. You want to see one of those ways more than the other?
The one that we did, I think.
So up here, I did split them up. You want to see that?
Yes.
Okay. Split them up. So it's negative 8 raised to the negative 1/3, and x to the 15 raised to the negative 1/3. Split them up. Now I just have to do one thing at a time. We'll look at the first piece, then we'll look at the second piece. First piece, negative 8 to the negative 1/3. Well, that's a negative exponent, right? So let's flip it. 1 over negative 8 to the 1/3. What's a 1/3 power?
A cube.
It's a cube root, right? If you turn it into a radical, it's just a cube root. What's the cube root of negative 8? Negative 2. The cube root of 8 is 2. Cube root of negative 8 is negative 2. So this is 1 over negative 2. Not too bad. So there's that piece. You guys have questions on that?
Can you leave it up for a second?
Yep.
Oh, I did it.
All right, let's look at the next piece. This one, x to the 15 to the negative 1/3. Again, negative exponent, so let's flip it. It's 1 over x to the 15 to the positive 1/3 now. Power raised to another power means what? Multiply them. 15 times 1/3. Has anybody ever pointed out to you that multiplying by a fraction is the same thing as dividing?
Yes.
Yes. So when you do 15 times 1/3, what are you really doing? You're really doing 15 divided by 3. What's 15 divided by 3? 5. Okay. Good with that? So we're done now. We just got to put the pieces together. I have this turned into this. So that's negative 1/2. This turned into this. 1 over x to the 5th. I'm going to put those together. I'm going to simplify them, right? They're both fractions. So you multiply fractions, you multiply the top, you multiply the bottom. Pretty straightforward. It's going to be negative 1 over 2x to the 5th.
Do we need it to flip or is it?
Like for this negative?
No, for like the negative 5. Oh,
Well, yeah,
I
it's
see what
supposed to
you're
be
saying. Yeah. My
Did I
answer
miss,
was
did I
just
miss a
like,
negative?
yeah, my answer was x negative 5 on top of negative 2.
Yeah, so then that's the same thing because you would bring the x
Yeah.
down, right? Yeah. All right. Each. Questions on this one at all? Starting to get heavy. Starting to get heavy. That's okay. We got one more and then we'll take a break. Hey. Yeah. Sure. Got one more and then it's break time. Woo! Gosh. After this one, you were probably thinking there's no way it can get better. There is. There is. I know that you guys are making fun of me.
I'm not making fun of, I want to cry. See, they're already crying.
Yeah. All right, so let's get through this. One's actually going to be a little bit faster than the other ones. Try to simplify what's on the inside, just like we did up here. Try to simplify what's on the inside. But we run into a problem. Numbers and then variables. 81 divided by 16. Doesn't work, right? 16 doesn't go into 81. So this doesn't divide. That's fine. It doesn't simplify. Can you do anything with these?
No.
No, why not?
Because it's variable.
They're different variables. So can you even simplify this at all?
No.
No.
It's so.
No. So instead, I'm going to take each piece. There's 4 pieces in there, right? 2 numbers, 2 variables. I'm going to take each piece, split them up, and give them all 1/2 power. Before I do that, what's a 1/2 power?
A square root.
It's a square root. 1/2 power is a square root. So I'm just giving each of these a square root. That's all I'm doing. Square root of 81, square root of y to the 16, square root of 16, square root of x to the 12. This is going to resolve pretty quick. What's the square root of 81?
9.
How many times is 2 going to 16?
8.
What's the square root of 16?
4.
And how many times is 2 going to 12? Okay, can you simplify 9 over 4?
No.
No. Can you do anything with these?
No.
No. Do you have any negative exponents? No. Do you have any radicals? Nope. So you're done. These ones. You can see we got 2 sections left, all right? 20 minutes, 2 sections left. I think you can do it. These ones are the same idea, but a little bit different approach.
Whoa.
Oh, look at all that.
I'm so sorry for the people at home. They're going to be so confused looking at this.
All right, these started with fraction exponents, right?
Yeah.
These ones start with radicals. Okay? Again, there's different ways that you can approach these. Maybe you might think, oh, I want to turn it into a fraction exponent. You could. I don't think that's really going to help you that much, but you could. What did we always start doing? Like, what was our first step on these
Separate.
ones? Separating, right? What do you know about these? They're already separated. Does 8 have a square root?
No.
No. Does 40 have a square root?
No.
No, it doesn't.
But we can simplify.
So maybe, let's put them together, maybe. Right, like I said, the first thing that you are going to do is either split it all up or put it all together. Pretty much always going to be the first thing you do. So let's put them all together. It's all underneath square root. It's going to be 8y to the 5th times 40y squared. Put it all together because they're underneath the same root. All right. Now I can simplify the things that are inside of there because they're going to multiply together. So we got to do numbers, then we do variables. What's 8 times 40? 320.
Yeah.
And what's y to the 5th times y squared?
Why?
Y to the 7th, because multiplying
It's adding.
means adding, right?
For someone.
Okay. All right, that might be kind of ugly a little bit, but I don't think it's as ugly as that, maybe.
I think it might be.
I think you should be changing it.
Now that we... Oh. Guys.
Canceled.
Okay, here we go. Now that we have put it all together, it looks a little bit better, let's split it up again. Okay, because then we can actually try to simplify it. Square root of 320, square root of y to the 7th. All right, I'm trying to simplify the square root of 320. Are there any perfect square numbers? They go in 320.
Well, the divisor, well, probably.
You did?
25 because it's the thing of 5.
No, 25 doesn't do.
25 doesn't do it?
No, it would make no sense to do it.
64 do it?
64 it does, it's 5.
64 times 5?
Yep.
Okay, so this is 64 times 5. And what's the square root of 64? 8.
It's 8.
All right, so this becomes 8 root 5. And then we can simplify y to the 7th, right?
Yeah.
How do you do that?
Well, you just see how many times 2 can go into
2 goes
7.
into 7
times.
3 times with a remainder of 1. So I have 8 root 5 times y to the cube times the square root of y. Am I done?
No.
No, I can put some stuff back together, right?
8 times y times 5y square root.
So 8y cubed and the square root of 5y.
Yes. Beautiful.
Yeah.
We all right with that?
I like this one.
Why would you want to be done? Ain't this the highlight of your day? Try. Well, let me ask you. Do you want to try these on your own, or do you just want us to crank through those?
We're crank through it.
Should we just get through it?
Yeah.
Okay, let's just get through it. Well, I'll kind of pick up the pace here because I have to.
I know that one.
All right, this one, same thing. Put it all together. Square roots of 7x to the 5th, 42xy to the 9. And then I'm going to simplify it. I'm going to multiply numbers by numbers, variables by variables. What's 7 times 42? What is it? 294. X to the 5th times x is what? X to the 6th power. There's a 1 attached to that, right? So you add them. And then I got a y to the 9th at the end of that. Okay? What should I do now?
Wait, give me a second. Okay, continue.
You write it down, that's okay. I'm going to break it up, just like I did here, right? I got it all together, now I can split it up, because I got my nice clean pieces here. So I will split it up. Square root of 294, square root of x to the 6th, and square root of y to the 9. Is 294 a perfect square? No. No, it's not.
Probably not.
All right, was there a perfect square that goes into it?
Wait, let me see. Give me just a little second.
49.
49 what?
6.
49 6. Okay, so that'll work. All right, so this, do I have any room? Yeah, kind of, sort of. This is going to be the square root of 49 times 6, which what's that going to turn into?
7.
Square root 6.
7 root 6, right? Because the square root of 49 is 7, and you got 6. All right, so I'm going to save some room here. That's going to be 7 root 6. How many times 2 going to 6?
3.
And how many times 2 going to 9?
4.
With a remainder of 1. Okay? So that's what I got, but I can collect some stuff, yes? I got square root of 6, I got square root of y. I can put those back together. Yeah? You tracking with me?
Yes.
So it's going to be 7 x to the 3rd, 2 pieces on the outside, and then a y. Oh, that's y before. Okay, and then the square root of 6y. Man, this is looking good.
Are we done now?
No!
Please don't yell at me. Make me fast.
Okay. We're getting there. We're getting there.
I thought you said we was the last one.
No, we still
No.
have time. 10 minutes.
So we got time.
I'm probably going to put them that tomorrow.
This is going to be lightning round. Lightning round. Unless you want to keep doing this tomorrow.
That's actually, guys. Let's do that. Write down these numbers. Just go. We've been doing this all class.
Hey, what's 3 times 2?
6.
Okay, combine these. Cube root of 5y cubed times 50y fourth. What's 5 times 50? 250 y to the 7th. Yes?
Yes.
You know how I got 7?
Yes.
Because 3 plus 4 is 7, right?
Yes.
Okay. All right, split it up. 6 cube root of 250 cube root of y to the 7. Is there a cube root of 250?
Yeah.
What is it? That's 125. I don't think there's a cube root of 250, but there might be a perfect square, or sorry, a perfect cube that goes into it. Perhaps 125. 125 times 2. Yeah.
25 goes into 250.
Yeah, but we need cubes, right? 25 is a square.
Okay, do you guys want, cube to 250?
So one,
It's not?
no, but 125 goes into it, right?
Yeah.
So I can write this as 6 times the cube root of 125 times 2 times the cube root of y to the 7th. And what's the cube root of 125? Okay, so it's 6 times 5 cube root of 2. 3 goes into 7 twice with a remainder of 1. Oh boy. Got a lot of pieces. Let's put it all together. 6 times 5 is 30. Oh my gosh. 6 times 5 is 30. And then a y squared. And then I put these together. Woo!
Can you scoop a little bit up?
Yes. Yes, yes.
I saw that yesterday. She sent me the video. Why did you guys do that?
All right. Guys, we have 8 minutes left.
Okay.
I'm going to give you the information that you need, and then we're just going to be done. Sound good? And then we're going to do something else tomorrow.
You have to write it down.
Well, it's similar stuff. Okay, we good?
Yeah.
Okay, last chunk, and then you guys are out of here.
Oh.
Woo, man, look at that. Oh,
Are we supposed to do
man.
that in 7 minutes?
This is the same approach as these ones, except now these get multiplied. These are getting divided. Same thing, you're just dividing now, okay? So put it all together and then simplify. I can write this as the cube root of 162 x to the 5th over 3x squared.
What if I start crying?
You want no balls?
I cannot cry. You're correct. I probably said I'm going to cry this morning. What?
What's 162 divided by 3?
54.
54. Cube root of 54. What's x to the 5th divided by x squared? Yep, divide means you do what?
Subtract.
So it's x to the 3rd. Break it up. Cube root of 54 times cube root of x cubed. Is there a perfect cube that goes into 54?
Probably.
27 is close.
Into 54?
Yeah. Oh yeah, it's times 2, huh?
Yeah.
Yeah. Okay, so cube root of 54, that's 27 times 2. Times 2. I need to be done.
Yeah, we're fine.
Times 2. What's the cube root of x cubed? X.
I really want to cry. You want some pictures?
Okay. What's the cube root of 27?
37.
3. So it is, where can I write this? Let's do it down here. 3 cube root of 2 times x. Is that how I want to write that?
No.
How might you want to write it?
I don't. Cube root 2?
I would do 3x cube root 2 because we want the radical to be at the end every time. We want the radical to be at the end, so we bring the variable over.
No.
And we're done.